Hello and welcome to How to Configure IPv6 on a Cisco Router webinar presented by veteran IT author and speaker Don R. Crawley with guest presenter CCNP Tom Davis. Don Crawley is President and Chief Technologist at SoundTraining.net, the Seattle-based IT training firm. He is also the author of the Accidental Administrator series of books for IT professionals, including the just-released Accidental Administrator Cisco Router Step-by-Step Configuration Guide. Tom Davis is a Cisco CCNP. He holds Silver IPv6 certification and is a lead on the California IPv6 Task Force. I'm Christina Bartz from TrainSignal, and I'd like to take a minute to tell you what to expect in the next hour. First, I'd like to draw your attention to the questions box in your webinar control panel. Don will be answering questions today, so please feel free to submit your questions during the presentation. Also, if you have any technical difficulties, let us know in the questions box and we'll do our best to assist you. Please note that everyone is on mute. Today's presentation will be recorded and available to view on our blog. We'll email you the link after the presentation. After you exit the webinar, you'll be prompted to take a short survey. TrainSignal wants to hear from you, so please take a few minutes to complete the survey. We will also be choosing one participant from today's audience to receive a copy of Don's new book, The Accidental Administrator Cisco Router Step-by-Step Configuration Guide. To be eligible to win, you must complete the survey that you will receive after the webinar. Be sure to fill it out. It only takes a few seconds. If you have any additional comments or feedback, you can email us at webinars@trainsignal.com. And with that, thank you for joining us for today's webinar. Here's Don.
Thank you very much, Christina, and good morning, good afternoon, good evening to you wherever you are. It's a pleasure to be with you through the TrainSignal webinar again. I want to give a shout out to my colleague Tom Davis, who's with us. Hi, Tom.
Hey, Don, how you doing? I'm excited to be a part of it.
Sorry to catch you off guard there. Tom was a participant in the book, the Cisco Router Step-by-Step Configuration Guide. He was my technical consultant. Tom and I have known each other for several years, and I asked him to participate in today's webinar because he's out in the forefront of IPv6 implementation, and he can give us some real-world stories from the field as we go through. So I've asked him to interject his real-world stories during the webinar and also to participate in the Q&A at the end. So Tom, it's great to have you here, and thank you for participating.
Thanks,
here's our outline of the webinar. We're going to go over how to assign IPv6 addresses to an interface. We'll talk about the types of IPv6 addresses, how to enable IPv6, static routing, dynamic routing with IPv6 RIP, IPv6 EIGRP, and single area IPv6 OSPF. We're going to touch on IPv6 access control lists, although honestly they're not a whole lot different from what you have with IPv4, and then we'll end with some IPv6 security considerations. As you can see, we've got a pretty aggressive agenda to cover in a fairly short period of time, so we're not going to go really deep, but I think that by the end of the webinar you should have a pretty good sense of how to implement IPv6 on a Cisco router. It's not terribly difficult, and we've also got some resources for you, some online resources to help you in the process down the road. Let's talk about types of IPv6 addresses. So there's really three types. There's unicast, multicast, and anycast. Broadcast messages are not used in IPv6, and anybody who's been involved in data networks for any length of time knows what a bane broadcast messages can be to network traffic and to bandwidth. So that's good news. A unicast is where the packet is delivered to a single interface. A multicast is the same as in IPv4, where a packet is delivered to multiple interfaces. But now we have an anycast address, and that's where a packet is delivered to the nearest of multiple interfaces, typically on multiple nodes. And Tom and I were talking about this while we were working on the book, and he commented that a great use of this is with DNS. So you can find your closest DNS server by sending an anycast packet out, and it then is based on routing information. It determines where the closest DNS server would be. So that's an example of an anycast address. Now, we have several IPv6 scopes. I'm not going to go over all of them, but I do want to touch on some of them. A link local scope is the local link. That's the nodes on the same subnet. Then you have a unique local where the scope is the entire organization, and then we have global, which would be the IPv6 internet addresses. Now, here are some types of IPv6 addresses. The Unicast global addresses are similar to IPv4 public addresses. Anytime you see the word global, that kind of indicates that we're talking about things out on the public internet. They're globally routable on the public internet, and they have a prefix of 2000:/3. Now, if you're not familiar with IPv6 addresses, I'm not going to go into a lot of detail on them. You'll see several examples as we go through the webinar, but it's a 128-bit address, and just the same as insider notation with IPv4 addresses, that slash value at the end indicates the total number of bits in the network portion of the address. So in the case of a Unicast global address, the first 3 bits are the network portion of the address. Now, you can obviously extend that through subnetting processes, but by default, in the case of the Unicast Global, the first 3 bits are network addresses. Then we have unique local addresses. These are similar to IPv4 private addresses. You may think of them as the RFC 1918 addresses. Well, when we get into IPv6, this is RFC 4193. And let me just mention that the RFCs are really, as always, a tremendous source of information on how to configure IPv6. And that is generally true, not just limited to Cisco. So when you want to know about IPv6, take a look at the RFCs, and we'll give you some RFC recommendations toward the end of the webinar, and also we've set up a web page to support that as well. Unique local addresses use the address block of FC00::/7. Now, one comment, again, for those of you who are brand new to IPv6, that : is a way of replacing a string of zeros. So if it comes at the end of the address like it does here, then that simply represents a lengthy string of zeros. It's shorthand. Next, we have Unicast link local addresses. These are similar to IPv4 APIPA addresses. They're configured by SLAC, and SLAC is the stateless address auto configuration. And the cool thing about SLAC is that, unlike APIPA, where everybody is pretty limited to the 169.254, with SLAC, what happens is you can configure the address on a router, and then a node which is configured to pick up its address through SLAC will pick up an address based on the network that you configure on the router that's providing the SLAC addresses. I'm going to show you that in a little bit. It is required for neighbor discovery. It's always automatically configured, and it uses the address block of FE80::/64. That's a little deceptive. I don't want to split hairs on this, but technically it's actually a /10, but the next 54 bits are filled in with zeros, so we'll go ahead and just call it /64. There are some other IPv6 addresses, as you'll recall from IPv4, with the loopback of 127.0.0.1. We have that as well in IPv6. It's : 1/1/128. We also have the Unicast unspecified address, which is equivalent to the IPv4 unspecified address of 0.0.0.0 used for setting default routes. This address can be specified by simply a : And then the documentation address block of 2001:DB8::/64. And you'll see us using that as we get into the demonstrations. Now let's talk about assigning a static address in IPv6. It's pretty straightforward. Here you can see I'm using a 1941 router to get the screen capture here, but in global configuration mode, you simply move into interface configuration mode. Whichever interface you need to configure. In this case, it was Gigabit Ethernet 0/0, and then you use a command very similar to how we would do it with IPv4, except that now instead of saying IP address, we say IPv6 address, and then we specify the address. And the mask is indicated with a / value, so you don't have to mess around with the traditional dotted decimal notation, and thank goodness for that. Then here in this example, I moved to interface Gigabit Ethernet 0/1, and same thing. So pretty straightforward, not a whole lot to it, and frankly, that part makes a lot of sense. We can also use auto configuration. So let's say that you have a device that is configured for IPv6, and you don't want to mess around with DHCP, and you don't want to mess around with a static address assignment, you can actually use auto-configuration to set the addresses. And in this particular case, I actually did it on a router. Again, this is on a 1941 router, but I went into interface gigabit Ethernet 0/0, and instead of assigning a static address, I used the command IPv6 address autoconfig. And what that does then is the router then queries its neighbor to find out what the network address is, and it assigns itself an address on that network. And you can also do it with DHCP as well if you have an IPv6 configured DHCP server. So pretty straightforward, as you can see. Now, this is the topology map that we're going to be using for the demonstrations as we go through the demonstrations later on. And just a couple of things to point out. We're really just going to be focusing on the routers here. We're not going to worry a whole lot about the computers. But as you can see, we've got 3 routers. And I'm going to be doing the demonstrations on router 2 in the middle. Router 1 and router 3 are both 871 routers configured with IPv6 and the Advanced IP Services feature set, and router 02 is using Cisco iOS version 15 and some variant on that. But that's where I'll be doing the demonstrations. And I've already configured router 1 and router 3 with static routes and routing protocols, but router 2 doesn't have those, and so it'll be those things will be implemented on router 2, and you'll see them as they come online. So let's get started with some of the demonstrations and some of the background in how to do this. First of all, in order to enable IPv6 routing, you have to use the global configuration mode command IPv6 Unicast routing. So let's actually just switch over to PuTTY and show you that. So we'll go into global configuration mode. So now we're in global configuration mode, and we'll issue the command IPv6 Unicast routing. And I just used the tab completion to do that, and so now that enables it. So pretty straightforward there, but that is required. Now, if we want to do static routing, the syntax is very much the same as it was with IPv4. And here you can see I'm on router 2, and I want to get to the remote network, which I've designated 2001:DB8:4. Which is the network on the outside of router 3. So I indicate the target network in the mask, just the same as I would do with IPv4. So I type IPv6 route, then the target network in mask, in this case 2001:DB8:4:/64. Now, just a comment, if you think about it, that /64 means we're using half of the address for the network portion, and that leaves us with 64 bits for hosts. Now, obviously, you would never have a network with 2 to the power of 64 hosts in it. I'm not even sure what that number is, but it's a huge number. But that is configurable, and in this case, that's what it is. So once we specify the target network in the mask, then we need to show how we're going to get there. Exactly the same as configuring a static route with IPv4. So we specify either the next hop, our neighboring router, and its explicit IPv6 address, or as you can see in the next line, we can choose to specify the interface from which we want to send the packets. Now, we should do that only in a point-to-point configuration, or generally that would only be done in a point-to-point configuration, but you can either specify the next hop, the neighboring router, or you can specify the interface from which you want to send the packets. Either one works. So let's go in and configure some static routes now so you can see how that's done. So again, I'm on router 2, and what I want to do is I want to configure a static route to network 1. If you'll think back to the diagram, network 1 is the network on the other side of router 1. So I'm going to use the command IPv6 route, and then I'm going to specify my target network, 2001:DB8:1, and then a whack, or 2 colons, and then a whack, and 64. So that's my target. And how am I going to get there? I'm going to get there by going to router 1's network 2 interface. So that's going to be 2001:DB8:2:101. And if I've done this right now, and doing these things live always makes me pretty nervous, but if I've done this right, I should be able to ping the interface on the other side of router 1 and get a response. So let's see if we can do that. So we'll type do ping 2001:db8:1:101, and let's see what happens. And look at that. I can breathe a sigh of relief because I was successful. Now, let's just take a quick look at the routing table. So we'll use the command do show IPv6 route. And the main thing I want to point out to you is right up at the very top, you'll see the static route. And that's the one that I just created. It says to get to the network 2001:db8:1:/64, I go to the node at 2001:db8:2:101. So really the syntax is almost identical to the way we did it in IPv4. What's different is that now instead of saying IP route, we say IPv6 route, and now instead of using the traditional old-fashioned IPv4 addresses, now we're using IPv6 addresses. So pretty straightforward. Now if we wanted, we could also configure a static route to the other side, but let's not do that, and let's go in and remove that route. So in order to do that, I'm going to type the command no, and then with my mouse I'm going to reach up here and grab this route that I just configured, and we'll remove it. And by the way, the reason I'm removing it is because we're about to implement dynamic routing, and a static route has an administrative distance of 1, so it would take precedence over any dynamic routes, and it would absolutely ruin the demonstration. So we don't want to do that, so we'll carry on without it. So let's go ahead and go back to the PowerPoint for a moment. Let's talk about IPv6 RIP. Now, the thing to think about IPv6 RIP routing is that it's very similar to IPv4 RIP version 2. It is a distance vector routing protocol, just like RIP, which means that it sends out its updates at regular intervals, sends the entire routing table. Unlike the way we configured RIP in IPv4, where we had to use network statements, now we go to each individual interface and we configure RIP on the interfaces that we want participating in the RIP routing process. So frankly, it makes a little more sense than the way we did it in IPv4. We still use the hop count to determine the metric, and there's a maximum hop count of 15, so that means that RIP in IPv6, just like it was in IPv4, is really only useful in smaller networks. You may recall how RIP RIP version 2 sent its routing updates to the multicast address of 224.0.0.9, and IPv6 RIP sends its update to the IPv6 multicast address of FF02::9. So here's how we configure IPv6 RIP, and I've got the slide, and then I'm going to go in and demo it for you. Again, we use the IPv6 Unicast routing command. I've already issued that, so I don't need to redo it. And then we go to the interfaces where we want to enable it. And so I went to interface G0/0, and I used the command IPv6 RIP. And then I need to use some kind of a text string to name the process. You could call it Billy Bob, doesn't matter. I just use process_01 and then enable. Now, let me make a comment about the processes. If for some reason you wanted to have multiple RIP processes running on a router, you could do that. So you could assign one the name RIP process_01, and the next one could be RIP process_02. But if you do that, the different processes are not going to talk to each other, but they are going to use up router resources. So you want to be careful about doing that. In general, the way to think about this when you're configuring IPv6 RIP is just give everybody the same process name, and unless you have a specific reason not to. So then I went to interface G0/1 and repeated the command. So let's go in and configure RIP on the router. So I'm going to go to, on router 2, the one in the middle, and I'm going to go to interface G0/0. Oops, helps to be able to type. And I'm going to use the command IPv6 RIP process_01. Again, that's just a text string. You could, name it Bugs Bunny if you wanted to. And then I'm going to use the command enable to enable IPv6 RIP. And while we're at it, let's go ahead and do interface G0/1, and we'll repeat the IPv6 RIP process 01 enable, and now we should have IPv6 RIP running. Let's use the command do show IPv6 protocols, and let's see if it's there. And indeed, there it is. And as you can see, it's enabled on gig 0/1 and gig 0/0. Let's see if it shows up in our routing table. So we use the command do show IPv6 route, and let's see if there's any RIP routes there. And indeed, there are. You can see we have 2 RIP routes. Here's one, and here's one. Let's try a ping and see if it works. So this time let's ping router 3's interface on the far side. So we'll do ping, do ping 2001:db8:4 /:301, and look at that, success. Again, I can breathe a sigh of relief. I always get nervous doing live demonstrations. Let's try it going to the far side of router 1 while we're at it. Just push our luck here and see what happens. So we'll change this to 101 and this to network 1. And again, success. So we're on a roll.
Hey, Don.
Now, yeah, Tom?
I just want to kind of inject here. When you look at that routing table and you see that RIP route, notice below it you'll see the link local address. That's because a routing protocol will actually use a router advertisement to determine the next hop link local address and use that for all communication. Just right up above 2 up, you'll see FE80::.
Oh yeah, right there. Yep.
That is a link local address generated on the distant router. And so when you're running a dynamic routing protocol, it's going to use that link local address for all communication.
That's an excellent point. Thank you, Tom. Appreciate that. And that again is the one that if I wanted to, just to continue with what Tom was talking about, I could configure router 2 that I'm working on to pick up its address via that same technology. So that's another option. Not even an option. That's just another part of it. Thanks, Tom. All right, let's go in and talk about configuring single area OSPF v3. Now, OSPF version 3 was designed to integrate seamlessly with IPv6, and just as with OSPF previous versions, there has to be a router ID, but in this case, unless you have OSPF version 2 running, where you've got a traditional IPv4 router ID, you have to assign a router ID. So if you're running a router that is just running IPv6, you have to manually assign it a router ID in global configuration mode, and that router ID can look a lot like a traditional IPv4 address. And just like RIP OSPF for IPv6 is configured on each individual interface. So here's the slide, and then we'll go in and configure OSPF. You can see that we're use the IPv6 Unicast routing statement to enable it, just like we did with static routes and with RIP. And then we start the OSPF routing process. So we use the IPv6 router OSPF, and then we give it a process ID. This is any number between 1 and 65,535. Then we go in and give it a router ID. Now, the router ID that I gave mine looks an awful lot like a traditional IPv4 address. The reason I gave it 2.2.2.2 is I tried to tie it in with a router name. You don't have to do that, but that was my goal in doing that. Then we go to each of the individual interfaces, just exactly the same as we do with RIP, and we enable the OSPF, and we identify the area where the updates are going to be exchanged. Now, as we said, this is single area OSPF. If you were working with multi-area OSPF, then perhaps that area would be different from area 0, which is usually the backbone area in multi-area OSPF. So let's go in and set up OSPF on the router, and you'll notice that I'm leaving RIP running. You probably wouldn't normally do that unless you had a router that was going to exchange updates with both RIP and OSPF networks, but for our purposes here, we'll go ahead and leave it running. So we'll back out, and let's first of all enable OSPF. So I'm going to use IPv6 router OSPF 10, and now we'll go ahead and give it a router ID, notice that it actually is complaining about it. It says I couldn't pick a router ID, so please configure it manually. Okay, I got the message. So we're going to do router-ID 2.2.2.2, and now we've got a router ID. Now, we still don't have OSPF running on the router because I haven't enabled it on any of the interfaces. So let's go in and do that now. We'll go to interface G0/0, and we'll do IPv6 OSPF 10 area 0. And we'll also do the same thing on interface G0/1. You'll notice, by the way, that now it has established neighborhood with its neighbor at 1.1.1. Let's go ahead and do the same thing here, and you'll see that same message come up as it establishes communication with router 3. So now we have OSPF running on both interfaces, and if we go in and take a look at the routing table, we should see, let's do show IPv6 route, and indeed there they are. And you'll notice that we no longer have RIP showing. It's still running, but it's not showing because OSPF has the lower administrative distance. And by the way, to kind of piggyback on what Tom was talking about there, you can see that link local address as well. Same thing with OSPF as with RIP. All right, so now we've got OSPF, we've got RIP running. What about EIGRP? Well, as with RIP, EIGRP is configured on the interfaces, still uses the concept of the autonomous system, and here you can see us configuring EIGRP for IPv6. Now, there's a quirk that I discovered when I was working on the book that I'll share with you as we go through this, but let's just go through it line by line. Again, at the top you see we enable unicast routing, so IPv6 unicast routing. Then we go to the interfaces and we enable the EIGRP on the interfaces. So there you can see we've enabled the Autonomous System 61, and that's just a random number that I chose. Then we go to the next interface and do the same thing. You'll also notice that I needed to give it a router ID, and this is the quirk, because on my 1941 router that's using version 15 of the iOS, the command is IPv6 router EIGRP 61 to associate it with the autonomous system, and then EIGRP router ID, and then the router ID. But on the 871 routers, which are running version 12 something of the iOS, you don't use the EIGRP statement, and so it threw me off, and just honestly just by bumbling around with it I finally figured that out, and then we issue the no shutdown command to enable it. So just be aware of the fact, by the way, that if you're working with a router running an older version of the iOS, you may need to play with that a little bit and make sure that it takes the router ID the way you want. You have to use the EIGRP or maybe not. Just depends on the router. So let's go in and enable EIGRP. So here we go. Oops, get to my notes. First of all, we're going to enable unicast routing. We've already got that done, so let's go to the interfaces again. I'll back out and let's go to interface G0/0, and we're going to do IPv6 EIGRP 61, and interface G0/1, same thing. And you'll notice we're not getting any messages about neighborhood yet. Let's go in and give it a router ID and see if that changes. So IPv6 router EIGRP 61 and EIGRP router-ID 2.2.2.2 and no shutdown. And there you can see, probably didn't need to do the no shutdown command, but that's kind of a habit that I'm in. But you can see now it's established neighborhood. And let's go ahead and try our pings just to see if we're on target here. So we'll do ping 2001:db8:1:101 and success. And let's go the other way just to just to live on the edge a little bit. So again, do ping. This time we'll do 301 and network 4, and again success. So let's take a look at our routing table. Do show IPv6 route, And you can see that now we're seeing EIGRP discovered routes, which are denoted with the D right there. D, of course, stands for EIGRP. That always made a lot of sense to me. And once again, you can see the use of the link local address, as Tom pointed out earlier. And we have one other one. Now, one other comment, as with IPv4 routing, we don't see the RIP routes. We don't see the OSPF routes, and the reason is because EIGRP has an administrative distance of 90, which is lower than RIP with a distance of 120 or OSPF with a distance of 110. So that's why, once again, we only see the EIGRP routes. And if we were to go in and put in static routes, then those would take over from the EIGRP routes. We're not going to do that, but just an FYI for you. So it's really pretty straightforward, as you can see, configuring the routing on a Cisco router with IPv6. And it's kind of fun when you first get those routes exchanged. And actually, let's go back in and take a look at a couple more things. Just to show you here, we'll do show IPv6 protocols. And you can see here that we've got RIP running, we've got OSPF, and we have EIGRP all running on the same router. And we could actually do debugging, and we're running a little ahead of schedule, so let's go ahead and do that. So you can see we'll do debug IPv6 RIP. And in a moment you'll see the updates going out there. And it's a lot the same as it was with IPv4. You can see that it's receiving responses from its neighbors and showing how to get to the remote networks. A little more information than what we got with IPv4 routing, but again, the same thing. And one other comment on this, that just as with IPv4, if you have multiple routing protocols running on a router, then they're using up resources. So real world, you probably wouldn't have RIP, OSPF, and EIGRP running on the same router. Let's go ahead and turn that off. So we'll do undebug all. Oops, you have to spell it right. There we go. All right. Now, we told you we were going to talk about access control lists, and again, there's a lot of similarities between IPv4 access control lists and IPv6 access control lists. Same rules apply as with IPv4 ACLs. Packets are compared against each entry in a list in sequential order until there's a match. Once a packet matches, then all subsequent lines are ignored. There's an implicit deny any at the end of every ACL. There are no numbered lists like there were in IPv4. Now we use named lists, and that honestly just makes sense. It's easier to work with. And also, since IPv6 makes extensive use of neighbor discovery, it is implicitly allowed in IPv6 ACLs. One thing that can come back and bite you on that, if you're not careful, is the use of a deny any statement could prohibit the exchange of neighbor discovery information on the interfaces where you've implemented that, so just be aware of that. So here's how we configure an IPv6 ACL. The syntax is the same as with an IPv4 access list, except that again we're using IPv6. So we say IPv6 access list, then we give the name of the list. And then we're in ACL configuration mode, and so we'll use a deny. We specify the protocol, and then you can either use a network here or a host. In this case, I used host. And we specify the host address, so we're going to block the host at FE80::222, etc., from going to any destination. And I could provide an explicit network there, or I could provide an explicit host, although I understand there's some quirks in that with the Cisco iOS, so just be aware of that. But at least in theory, I can do that. And then I added another line, as you can see, and then at the very end of it, I wanted to permit IPv6 any. So that actually allows all traffic through except that which I've explicitly denied, as you can see from the demonstration. Now, in order to make that work, we have to use the IPv6 traffic filter command instead of the access group command. We have to use IPv6 traffic filter on the interface. So in this case, I went to interface G0/0, and then I use the IPv6 traffic filter and I specified the name of the access control list and then the direction of the list, which, same as with IPv4, in or out is from the perspective of the router. So we don't use access group, now we use traffic filter. Not sure why they felt the need to change it, but they did. So that's really all there is to configuring IPv6 ACLs at a high level. A lot of the same concepts apply as working with IPv4. This is an IPv6 ACL that is designed to permit only telnet traffic. I'm not sure why you would want to do that, but if you wanted to, this is how you would do it. And you can see that by using the statement permit TCP, so again, we're using the layer 4 adjustment there, going to any, from any source, going to the destination at 2001:db8:1:/64 equal telnet. That will allow any host to go to that particular network, the 2001 DB8.1 network, using telnet. And it will disallow any other traffic because you'll notice that there's no permit any statement following that. Couple of things as we get close to wrapping up. IPv6 security considerations. Physical security, same thing as with any other network security. You have to start with physical security. So IPv6 doesn't really address that, as you would imagine. It's a layer 3 protocol, but certainly you have to start with physical security. And then one of the things that you need to think about is management remote access. And in the same way that you can limit management remote access with Telnet or SSH or the Cisco Configuration Professional, or if you're using an ASA, the ASDM, you can limit it with access control lists and configuration statements in the router's configuration. You have to do that with IPv6 as well. One other thing that is kind of new to thinking about with IPv6 compared to IPv4 is that we have an opportunity, because of the huge number of addresses that are available to us, to create an obscure addressing scheme. And in IPv4, we really didn't have that option because there's so few addresses. But with IPv6, since mathematically there's 2 to the power of 128 or 340 undecillion addresses, we could create a very obscure addressing scheme for use in our network, which would make it unrealistic for the bad guys to try to guess what our addresses are. So something to think about as you design your addresses. And then finally, as you think about IPv6, you've got to remember to treat it as a separate independent protocol. So whatever you configure in IPv4 will be bypassed by IPv6 unless you explicitly configure it. In other words, your access control list in IPv4 will have no effect whatsoever on IPv6 traffic. If you're blocking IPv4 traffic, then you need to be sure and do the same thing with IPv6. So no IPv4 security will apply to IPv6, and you need to bear that in mind as you think about your designs and as you audit your security.
Hey, Don.
Yeah, Tom.
I was just going to say, if you go back to that one slide, I know there's probably a lot of people out there thinking that we don't run IPv6 on our network, so we don't have to worry about the security vulnerabilities. Just keep in mind that a lot of operating systems these days are coming with IPv6 enabled by default. So there's probably a lot of IPv6 on your network right now, and you got to keep that in mind when you're taking a look at your security policy.
That's an excellent point. Thank you for bringing that up. Certainly Windows 7 has IPv6 enabled by default, and Linux distros are now enabling IPv6 by default, and so you're absolutely right. Should you turn it off, and that's a good question, that's a question that you'll have to decide on your own. In a small network, if you're using Windows Home Group, it makes extensive use of IPv6, and so you may not want to turn it off there, but in an enterprise environment or even in a small business environment, you may want to disable it until you're ready to fully deploy it and until you're able to button things down. That's a great point. Thanks, Tom. All right, so IPv6 troubleshooting. In the book, I go through a lot of the troubleshooting commands, but as with IPv4, 2 of the most helpful troubleshooting commands that you're going to work with are show IPv6 interface brief and show IPv6 route. And let's just go take a look at both of those and the output from them. First of all, do show IPv6 interface brief. And there it shows you, just the same as it does with IPv4, it gives you a summary of your interfaces and how they're configured. And as you saw, we were using the command do show IPv6 route. And same thing again. These two commands, between these two commands, you can see, first of all, are your interfaces configured and what addresses are assigned to them, and then you can find out what the router knows about in terms of remote networks. So by taking a look at the routing table, we can see that this router knows about the 2001 DB81 network, and it discovered that through EIGRP. You can see right there. And it also knows about the 2001 DB84 remote network, also discovered through EIGRP, and how it's getting there. So using the link local address, it shows you how it gets to the remote networks. So these are very, very helpful tools. And I showed you earlier the show IPv6 protocols, but that shows you the protocols that you have running. So do show IPv6 protocols. And it'll show you which protocols are running. In this case, you can see RIP is running OSPF and the EIGRP, and the interfaces on which they're enabled, and so on. If you want to get more information about the interfaces, same thing as with IPv4. Do show IPv6 interface, and you can specify the interface if you want to filter the output. So let's just look at gig0/0, and here it shows you that IPv6 is enabled. It shows you the link local address. It also gives you the global unicast address that's enabled. So again, quite a bit of information in using the show interfaces command. And you can also debug. As you saw, I used IPv6 RIP debugging earlier, and you can do that with EIGRP and OSPF as well. In fact, there's quite a bit of debugging that you can do. Let's just use the command do debug IPv6 and put a question mark in it. Yeah.
Don, before you execute that, this show IPv6 interface command, I can't talk enough about it. It gives you so much information. If you take a look at it, you're going to see your link local address, which was automatically generated by your router based on its MAC address for that network card. You're going to see your global address. And keep in mind, with IPv6, you can have a number of global unicast addresses on one interface. Unlike IPv4, when you put an IP address on it, it would overwrite the previous one. This one, you can have a number of IPv6 addresses, and all of those will be listed right here.
You know, that's a good point, Tom. Because I discovered that when I was working on the book and writing the documentation, suddenly I had an interface that had a ton of global addresses on it, and it was because in IPv4 we're accustomed to, we assign it the address and it removes the previous one, but that's not the case with IPv6. That's a great point. Thank you.
Yeah, and you're gonna see your interface joining a lot of groups too. I mean, I encourage you all to go and do some research on some of these well-known multicast groups right there. The MTU size is going to be the same, and then you're also going to see a data temp down at the bottom where you see DAD in capital letters. What that is it's duplicate address detection, and any address you assign on your interface, what it's going to do is it's going to send out a router advertisement to that address to determine if that address is already being used. So it has a little bit of error prevention in there as well.
That's a good point. Also, just to go back, remember we talked about IPv6 RIP using the multicast address of FF02::9, and right there is the multicast group that it joined because IPv6 RIP is enabled on this router. So excellent point. Thanks, Tom. Anything else you want to add on that, or is there any other command you want me to show?
No, I mean this one will tell you a lot about how how IPv6 and IPv4 addressing just kind of, there's a lot of differences, a lot of great things when it comes to IPv6.
My experience with IPv6 is that ultimately it's a lot easier to work with than IPv4, and it's very modern. And IPv4 is really, it's a very old protocol, and it's showing its age. And IPv6 just makes a lot more sense. And honestly, you know, I've worked with fairly small networks. I don't want to second guess any of my clients or friends like Tom who work with large networks, but from my perspective in working with small networks, I really can't wait to implement it. I realize, of course, in a larger network that's a huge task, and I don't mean to underestimate that, but it really does bring a lot of benefits.
Well, I think the initial migration from v4 to v6 is going to be there's going to be a lot of lessons learned, I guess you could say. But once you get there, the efficiency of IPv6 is going to help tremendous.
Well, that's been your experience, as you and I have talked about. I mean, one of the things that you've been very clear about is the learning process and the learning curve on it, and I think that's absolutely true. We've set up some IPv6 online resources, and the book has a companion page on our website. It's at www.soundtraining.net/Cisco Router Book. And this web page is under construction, so you're going to go there and you'll see a lot of statements about under construction. But if you go to chapter 14, you'll find a lot of links to IPv6 resources that Tom and I've gathered for you. Also, I can't overestimate or promote the reading of the RFCs. So here's a group of them, and they're on the book's webpage as well. And you don't have to have a copy of the book to use the book's website. So take a look at that, and hopefully you'll find that helpful. In summary, and Tom, jump in on this, but IPv6 is going to be the main protocol of the global internet, and it's coming, and it's not too far away. And I talked to some students of mine who are with a large healthcare concern in the Seattle area, and I said, when are you going to implement IPv6? This was about a year ago, and they said, never if we can help it. But the reality is that it is coming. And I think about years ago when I was teaching classes and I had Novell NetWare admins who said we're never going to switch off of IPX SPX, and yet how many people are running IPX SPX today? Ultimately, you probably are going to make the switch, and some of us will do it because it's a huge job. I don't want to underestimate that, but some of us will do it, being dragged kicking and screaming, but it's one of those things where the more you know about it, the better equipped you're going to be when it finally does come time to implement it. And it's probably going to become the dominant transport protocol in our private networks in the not too distant future. And it does offer significant benefits over IPv4, including security. Security is engineered into it as opposed to IPv4, where we had to develop security as an afterthought through IPsec and other technologies. The packet headers are shorter. So in spite of the lengthy address, the packet headers are smaller, which should make it switch faster, and it also offers end-to-end connectivity, so we can eliminate NAT and problems associated with that. So a lot of benefits for working with IPv6 compared to IPv4. I don't want to understate the challenge that many, maybe most of you, are going to experience in trying to do the transition. But ultimately, I think, as Tom said, you'll find that the benefits are absolutely worth it. Here's a list of some other resources that we have for you at soundtraining.net and TrainSignal. I blog at soundtraining.net/blog. You can like us on Facebook and Twitter as well. Follow us on Google+. We've got more videos for you at soundtraining.net/videos. And I can't say enough about the videos at TrainSignal. If you're pursuing certification, the videos at TrainSignal are outstanding, and they're going to help you every step along the way. Well worth your time and investment. And also, petri.co.il is a great resource, and I found it very helpful when I was actually writing the IPv6 chapter in the router book. So those are some resources that hopefully you'll find helpful. And if you'd like to get the companion book, we'll just throw in a quick plug for that. You can visit our soundtraining.net/bookstore and pick up a copy of the Cisco Router Step-by-Step Configuration Guide. As of today, it is only available in paperback, but we're working on the Kindle edition and should have that out hopefully within a couple of days. So hope this has been helpful. Tom, I can't thank you enough for your input and for participating in both the book and the webinar. Thank you very much, my friend, and with that, we'll turn it back to Christina.
Thanks, Don and Tom. That's all the time we have today. Thanks again for attending and for your participation. As a reminder, today's webinar was recorded and will be available to view at trainsignal.com/blog/webinars. We will also email you the link by the end of the week. And remember, please fill out the survey for a chance to win a copy of Don's new book, The Accidental Administrator, Cisco Router Step-by-Step Configuration Guide. We will email the winner by the end of the week. Thanks again and have a great day.